All right, let's jump right into this. If you've been following the AI space lately, you have undoubtedly heard two specific terms getting thrown around, often totally interchangeably. Those terms are open source AI and open weights AI. But here's the critical thing we need to understand. They are absolutely not the same thing. They represent fundamentally different approaches to how AI is shared and built. Today, we're diving into a brilliant article by tech writer Sram Gopalan titled Open Source AI versus Open Weights AI, What's Actually the Difference? In this explainer, we're going to untangle these buzzwords and show you exactly why knowing the difference is just so vital for the future of your AI projects. To clear up the confusion right out of the gate, Sriram Gopalan gives us this fantastic analogy. He calls it a tale of two restaurants. This framework is going to be our guide today, and it does an amazing job of taking some highly complex technical jargon and grounding it in something we all understand perfectly, getting a really great meal. All right, section 1, the restaurant analogy, the recipe versus the finished dish. So picture this. Imagine two five-star restaurants opening on the exact same city block. They're both exceptional, and they both happen to serve the exact same signature dish, a slow braised lamb with a phenomenal sauce. But look at how their approaches differ. At Restaurant 1, the chef believes food should be entirely democratic. When you finish your meal, she hands you a card. On it is the complete recipe, the exact ingredients down to the gram, the supplier she orders from, the specific oven temperature, the resting time, literally everything. You can go home, cook this dish yourself, modify it, or even put it on the menu of your own restaurant. That is true open source AI. Now let's look at Restaurant 2. This chef is also incredibly generous, but in a totally different way. When you finish your meal, he sends you home with a full, sealed, ready-to-reheat portion of the lamb. It's completely free. Take as many as you want, serve it to your family, or even sell it. But, and this is the key difference, the recipe stays locked in the kitchen. You don't know if he used fresh or canned tomatoes. You can't cook it from scratch because you only have the result, not the instructions. That is open weights AI. Both are deeply generous, but what they're actually giving you is fundamentally different. Which brings us to section 2, translating AI model anatomy, what open actually means. So, how does this restaurant story map onto actual machine learning architecture? Let's start with model weights. These are the billions of numerical parameters that encode what an AI model has actually learned. When you download a popular model today and run inference on it, asking it to write a poem or summarize a document, you are exclusively using the weights. In our analogy, the model weights are the finished dish. It's the braised lamb, fully cooked and ready to eat. Then you've got the training data. This is the massive corpus of text, code, or images that shape those weights during the learning process. And this perfectly illustrates the ingredient list and the supplier manifest of our restaurant. Knowing the training data is just essential if you want to know exactly what went into the system you're using. Next up, we have the architecture and training process. This includes the structural design, the specific hyperparameters, and all those choices made during human feedback fine-tuning. This is basically the chef's execution. It's the accumulated technique, the oven temperatures, and the intuitions that magically turn raw ingredients, the data, into the final weights. So with all that in mind, what does true open source AI actually look like? Well, it requires full reproducibility. It means you get the weights, the training data, the architecture, and the source code, the whole shebang. You get the scientific transparency to examine the system fully. You get true ownership, meaning you aren't dependent on the original creator, and the community can actually develop the underlying model. Genuine open source models are pretty rare, but some notable examples include Eleuther AI's GPT-NeoX or the Bloom model. They hand you the entire recipe so you can audit, modify, and retrain it from the ground up. But okay, here is the reality check. Most of what the tech industry casually calls open source AI is actually just open weights. The vast majority of the popular models you hear about give you that beautifully cooked, reheatable dish for free, which is awesome, but they firmly keep the recipe locked away in their proprietary kitchens. Now look at how this plays out with today's biggest AI players. We've got Western heavyweights like Meta's Llama family. They offer downloadable weights with a custom license, but the training data is completely proprietary. Then you have Mistral, which has a very permissive license, but again, the training process is proprietary. And look at Alibaba's Qwen family, an incredibly prolific set of Chinese models. They're highly capable, released generously for free commercial use, but the training data and methodology, absolutely not disclosed. They are all master chefs handing you a free meal, but they are all firmly in the open weights category. Moving on to Section 3, the DeepSeek complication, openness on a spectrum. So here's where things get super interesting. DeepSeek, a Chinese AI lab, really complicates our neat little taxonomy. On one side, you have DeepSeek's unprecedented openness. When they released their R1 reasoning model, they didn't just publish the weights. They published detailed training methodologies, reinforcement learning approaches, and they did it all under a standard, highly permissive MIT license. This allowed researchers all over the globe to meaningfully build on their work. But let's look at the other side, the opacity. DeepSeek operates under Chinese law, meaning its training data naturally includes content filtered through Chinese regulatory constraints. Its models exhibit specific behaviors reflecting those constraints. This presents organizations with a genuine, impartial dilemma. You get incredible technical transparency and reasoning capabilities, almost the whole recipe, but the exact provenance of the ingredients remains opaque. It just proves that openness in AI is a spectrum, not some simple binary choice. And, we absolutely have to touch on the legal wrinkle here, too. True open source typically utilizes predictable, legally tested standard licenses, like Apache 2.0 or the MIT license that DeepSeek used. Open weights models, on the other hand, often rely on custom licenses. Meta's Llama, for example, prohibits use by applications with more than 700 million monthly active users. Now, for a hobbyist, this doesn't matter at all. But if you are building a commercial product, your legal team needs to carefully review these custom open weights licenses every single time a new model drops. All right, Section 4, Choosing Your AI Menu, a practical guide to model selection. So, how do we actually apply Gopalan's framework to make the right choices for your own projects? Well, open weights is actually the right starting point for most developers. You're going to want to use open weights if you're looking to avoid those per-token API costs from closed models. It's perfect if you want to take a highly capable baseline and fine-tune it on your own proprietary data locally. It's also ideal if strict privacy is required, meaning your prompts literally never leave your servers, or if you simply need smaller, faster, task-optimized models like Microsoft's Phi 3 or Google's Gemma. For most day-to-day business needs, the finished dish is an extraordinary, cost-effective starting point. But here's the crucial point. Knowing when that finished dish just isn't enough. You must seek out true open source. If you are a researcher auditing training data for safety or bias, you absolutely need it if you have to reproduce and verify a model's behavior for strict regulatory compliance. If your goal is to contribute to the underlying base model itself, or if you're operating in highly regulated domains like healthcare, finance, or law where full auditability might be a strict legal requirement, you need the kitchen's full recipe, no exceptions. And lastly, there are very specific, highly capable edge cases for utilizing Chinese open weights models like Qwen, Yi, or DeepSeek. You should consider these if you require strong multilingual performance, particularly for East Asian languages. They're also fantastic if you're simply trying to maximize your performance per dollar, or if you want access to transparent reasoning architectures. That said, you always have to impartially evaluate your own regulatory and compliance constraints if data sovereignty and ingredient provenance are hard requirements for your business. Which brings us to our final, really important question to leave you with today. Which restaurant are you actually eating at? The democratization of AI over the last few years has been nothing short of miraculous. Labs all around the world are serving up remarkable technology. But the next time someone tells you a model is open source, stop and ask yourself, are we getting the recipe or just the dish? And if it's just the dish, do you know where those ingredients actually came from? Understanding that difference is exactly how you bridge the gap between building a cool prototype and building a compliant, sustainable AI product. If this explainer helped clarify the AI landscape for you, please hit that like button and subscribe to the channel so you don't miss our upcoming deep dives into the frameworks shaping our digital world. Thank you so much for joining me, and I'll see you in the next explainer.